the discriminant. So discriminant is part of our quadratic equation, and it tells us how many intercepts we have, whether we have 2 x-intercepts in our quadratic, we have 1, or we have none. So that's why we use it. So this is our quadratic equation, and we're considering this bit here, the bit under the square root. So if that bit there is 0, then all we have is negative b on 2a. So we know that that would only give us one solution. If this number is positive, like you should have done with your quadratic equation, you get 2 answers, or 2 solutions. And you cannot take the square root of a negative, which is why, if this number comes out as negative, there are no solutions. Cool. And so that bit under the square root is called the discriminant. We use this little triangle, this little delta, to represent the discriminant. So if you see that, that's what I mean. So whenever you're talking about the number of solutions, we are talking about using the discriminant. We don't actually want to solve it, we just want to know how many solutions there are if we solve a quadratic. Okay, so we remember that this is A, B, and C. So we sub those bits into our discriminant. So B squared minus 4AC. They're quite gross big numbers. Why on earth would I use those? So we've got 16 squared, which is 256. And negative 4 times 2 times 32 is minus 256. So we come out with 0. So that tells us there is one real solution to this quadratic. So if we factorized it and got to an x value, there would only be one answer rather than 2. Okay, so with our next one, once again, we've got A. Oh, that was weird. With our next one, once again, we have A, B, and C. The negative is included, although it doesn't matter with the B because we're squaring it. So we've got negative 13 squared minus 4AC. So that gets us 169 minus 16 times 8. Such big numbers. 128. Which gets us 41. So because that is a positive value, we know there will be 2 real solutions. Cool. We use this word real because you can have imaginary solutions. That's something that happens when you get to different axes, but we're not dealing with that, so we're always going to say we have real solutions. Okay, with our next one, so A is 1 for this one, B and C. So B squared minus 4AC. So 81 minus 60 gets us 21. So therefore, once again, we have 2 real solutions because our answer is positive. We also want to talk about the type of solutions we have. So we want to talk about the number and the type. And the type comes down to this rational numbers thing. Okay, so if a number is rational, it can be written as a fraction with a whole number on a whole number. So here we have a half. So that's a whole number on a whole number, so that is rational. 5 can be written as 5 on 1, so that is rational. Square root of 2 cannot be written as a fraction. So it ends up as 1 point something, 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 something. So because we cannot get that into an actual fraction, that is not rational or irrational. Another irrational one is pi. Because pi is 3.1415, continuing on, we can't get that into a fraction, so that is irrational. So there's 2 general cases of when you'll have rational solutions. You should have a rational solution when you get your discriminant equals 0, or when your discriminant is a perfect square. So for example, like 25. Because if we take a square root of 0 or a square root of 25, we get rid of that square root, which gets rid of our surd, So we get a rational number. So that's what we're looking for. So discriminant b squared minus 4ac. So 64 minus 40 is 24. So for this one, we get to the fact that we have two real solutions because we've got a positive number. And because this is not a square root, they are irrational solutions. All right, another one. Discriminant equals negative b squared minus 4ac. So that's 25 plus 24, which equals 49. So because 49 is a perfect square, it's 7 squared, that one has two real rational solutions. Cool. So chapter 3i, page 118, do all of them.